Problem number 24 on your homework. Once again, yes, I realize the homework skips around. Asks us to use the quadratic formula to solve for the roots or the x-intercepts of the problem. 2n squared minus 8n is equal to negative 8. Okay, so the two things that we need to know. We need to refresh our memory of the standard form of a quadratic. Which is ax squared plus bx plus c equals 0. We also need to make sure that we know what the quadratic formula is. Quadratic formula, using a quadratic equation in standard form, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now that we have that out of the way, we're actually going to use it. Okay, so we've got to make sure that our equation is in standard form. That means it needs to be equal to 0. So I'm going to have to add 8 to both sides, which will give me. So now we have 2n squared minus 8n plus 8 equals 0. So fitting that with our standard form, that's ax squared plus bx plus c equals 0. That means my a is 2, my b is negative 8, and my c is positive 8. So I'm going to plug that into the quadratic formula. So I've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I've got negative 8 plus or minus the square root. Well, my b is negative 8, so negative 8 squared minus 4 times my a is 2 times my c is 8. All over 2 times 2, because a is 2. Okay, so what does this equal? Well, a negative times a negative is a positive, so we have positive 8 plus or minus the square root. Negative 8 squared is negative 8 times negative 8, which is positive 64. All right, 64 minus 4 times 2 is 8, and 8 times 8 is 64. So we have 64 minus 64 all over 2 times 2, which is 4. Okay, so that gives us 8 plus or minus the square root of 64 minus 64 is 0 over 4. Well, that gives us 8 plus or minus, the square root of 0 is just 0, because 0 times 0 is 0 over 4. So we would have 8 plus 0 over 4. Well, 8 plus 0 is just 8. 8 over 4 is 2. Okay, we can have 8 minus 0 over 4. Well, 8 minus 0 is just 8, and 8 over 4 is 2. So both of these are the same. So the only thing that x can equal is 2. There's only one root here. We get 2. We get it twice. You can do it twice. More. Problem number 26. We're asked to simplify. We have 20x over 12x. Well, we can see right away that the x's make a 1. So you now have 20 over 12. Well, 20 and 12 are both divisible by 4. So 4 times 5 is 20. And 4 times 3 is 12. Therefore, my 4's make a 1, which leaves me with 5 over 3. $34 is the problem -2 r to the -4th times -r squared times r to the -2. When we multiply and we have exponents, as long as we have the same base, we can add our exponents. Now, the first thing we're going to do is multiply our coefficients. So here we have a -2. So I'm going to have -2 times, my coefficient here is -1. So -2 times -1. And everything else is r to the something. So I'm going to have r to the -4 plus 2. This was -4, this was 2, plus -2. Okay, -2 times -1 is +2. Then we have r to the -4 plus 2, which is -2. And -2 plus -2 is -4. We know that when we have a negative exponent, if we move it to the other side of the fraction, it becomes a positive exponent. So this becomes 2 over r to the 4th. Problem 36 asks us the square root of 192. Now to simplify radicals, we need to figure out what the largest perfect square is that goes into that number. So we need to list our perfect squares. So we have 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. We could go on. You're responsible up to 15. Well, let's figure out what goes into 192. Ideally, we do want to find the largest perfect square that goes into 192, but as long as we find any perfect square that goes into 192, we're on our way. So let's see. 4 is going to work, but maybe I can find something bigger. Not quite sure. So let's just go with 4. So we have 4 times 25 is 100, and 4 times 23 is 92. So that's 25 plus 23 is 48. Now the square root of 4 is just 2, so it comes to the outside. And we're left with the square root of 48. Well, we know that 4 goes into 48. 48 is a little smaller. We can work with it a little easier. Let's see if anything bigger goes in there. 9, no, that doesn't work. 16, yes, 16 works. So we have 16 times 3 gives me 2 times the square root of 16 is 4, so it comes outside. And we're left with the square root of 3. We can't simplify the square root of 3, so we just leave it. 2 times 4 is 8. 8 square root of 3. That's our final answer. 8 square root of 3. Okay, we have one last problem from the homework. Problem number 40. It also involves simplifying radicals. We have the square root of 15 times 5 plus the square root of 10. We can distribute. Now, if something's on the inside of a radical, it stays. If something's on the outside, it stays. So the 5 is on the outside, so it stays on the outside. The 15 stays on the inside. Plus, these are both on the inside, so they stay on the inside. 15 times 10 is 150. Now let's see if I can simplify any of these. Square root of 15, let's see, 1 and 2 don't help us. 4 doesn't go into 15. 9 doesn't go into 15. 16 is already too big, so we can't simplify the square root of 15. We're just left with 5 square root of 15 over here. Let's see if we can simplify the square root of 150. I see something that goes in there, 25. 150 is 25 times 6. So I have 5 square root of 15 plus the square root of 25 is simply 5 times the square root of 6. Can I break down the square root of 6? Nope. 4 doesn't go into 6. 9 doesn't go into 6. I'm going to rewrite this so you can see it very clearly. My final answer, I'm left with 5 square root of 15 plus 5 square root of 6. I can't do anything else. This is all I have.